Hey everybody, it's Mr. Carr again. Today we're going to be talking about 6.1, day 2, properties of what's called isosceles, isosceles and equilateral triangles. Now, one thing I don't really like a whole bunch on this is that we didn't define these really. So I'm going to define it right here real quick. Isosceles, that is when at least two sides of a triangle are congruent. Okay, so that's an isosceles triangle. At least two sides of it are congruent. Equilateral, you probably do know. Okay, equilateral is when it's all three sides of a triangle are congruent. Okay, so that's what we're that's what we're focusing on today is isosceles and equilateral. Kind of an interesting thing here is isosceles, because you notice if I said at least two sides are congruent, technically speaking, an equilateral triangle can be considered an isosceles triangle. But I don't always go the same way. If I have an isosceles, I don't necessarily have equilateral. Okay, so the first thing we want to talk about is kind of demonstrating this image, but let's talk about the theorem first. If two sides of a triangle are congruent, then the angles opposite them are congruent. Okay, so that means if I look at that diagram, so if AB, and really technically speaking, the base angles theorem is going kind of I don't like this. I'm going to redraw that diagram. Here's what I'm really saying for base angles theorem. ABC, AB, and AC are congruent. Yeah, that doesn't match up at all. Ugh. Tell you what, ignore that. I'm just going to go focus on this. I'm just going to draw the scenario here. I don't like this without a good diagram, so blah, blah, blah. Okay, so what we're really doing is something like this. A, B, and C. A, B, and AC are congruent. So what that implies is that the angles B and C are also congruent. So angle B and angle C are congruent to each other. So this is what happens in an isosceles triangle. If I know that a triangle is an isosceles because they're sides, I also know that these base angles are congruent as well. Now the converse, if you remember converse, that means I'm going to go reverse. The converse is going to state if a pair of angles, a pair of base angles here are congruent, okay, so I have triangle ABC, that implies that their opposite sides are congruent. So AB is congruent to AC. Okay, so that's what we're saying here. These imply each other. Okay, so if I have sides that are congruent, they're opposite angles. I should kind of highlight that, I feel like. Okay, no, I'll just do a different color here. Okay, opposite angles here. Kind of cross there to get to those opposite angles. When I have the angles match up, their opposite sides are congruent. So when I look at this scenario here, it should be pretty straightforward. In triangle GFH, FH is congruent to GH. Name the two congruent angles. I'm just going to go straight across to G and F. Angle F is congruent to angle G. That's it. Opposite angles are congruent there. All right. If the perimeter of the triangle below is 35, what is the value of X? All right. So in this scenario, I'm telling you that these two angles are congruent. So remember what that means. If the two angles are congruent, their opposite sides are congruent. So here's what I can do in my problem. I can consider this to be X as well, since that's going to be the same as the other one. So here's my perimeter. I'm going to take all three sides and add them up. X plus 15 adds up to 35. Okay, so that means X plus X is 2X plus 15 equals 35. Subtract 15 over. So that 2X is equal to 20. And then I'll finish up by dividing by 2, so I get X equals 10 as my final answer. All right, that's all it is. We're applying these properties of our isosceles triangles, and it has to do with those opposite angles being congruent to each other. Example B here. Angle 2 is out here. Okay, this one's kind of a fun one for sure. It's going to take multiple steps. The first thing I want to mention is that since I have this is congruent to this, then this angle here is congruent to this angle there. Okay? There's actually multiple ways I could do it, but I'm going to start with this way. Because if I look at, so that means opposite there is congruent. I'm going to call them x's for now. Call them both x and x. So that means x plus 120 equals 180. X's to come together as 2x, subtract the 120 over, I get 60. X is equal to 30. Well, this was 30 degrees here. If I look at that being a right angle, and it gets split up as a 30-degree angle, and this other one, that's going to make that a 60-degree angle. Okay? And if that's a 60-degree angle, that means that this right here makes a linear pair. Hey, that's coming back again. So that means that's going to be 60 plus angle 2 equals 180. So that angle 2 is going to equal to 120 degrees. Okay, this wasn't the only way to get there. I could have done a linear pair here first, and then I have my isosceles here, and I could have done something very similar. Okay, next problem. Same thing, find x in the measure of angle r. Here are my congruent sides. Okay, well, sorry, here's my congruent sides, which means my congruent angles are r and q. So that means that I can consider this to be 2x as well. So I'm going to take this as 2x plus 40 equals 180. So I'm applying my interior angle theorem from before. So 2x plus 2x is 4x plus 40 equals 180. 4x equals 140. And let's divide by 4. That's going to give me 35. Okay. So x is 35. I have found that step. Now I need to find the measure of angle r. The measure of angle r is going to be 2 times 35, which is going to give me 70 degrees. That's really all we're going to do. We're going to work with it's really identifying those congruent sides and then which angles are congruent. Or I didn't do any of these. Well, I didn't know I did that. Or I'm identifying congruent angles and then figuring out which sides are congruent. Okay? So that's what we're focusing on in this part. The next part is a slight extension. That's equilateral triangles. If a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then it is equilateral. What does that mean? It's weird. It's kind of goofy. Bottom line is equilateral, we said all 3 sides are the same. Equiangular, all 3 angles are congruent. That's it. And it's very much interchangeable, but just recognize that if I say equiangular, I'm referring to angles. If I say equilateral, I'm referring to sides. Here's the thing. Since all 3 sides are the same and all 3 angles are the same, it does not matter what kind of equilateral triangle I'm working with. If I apply my idea of my interior angle theorem, that all 3 angles add up to 180, which means 3x equals 180, that means no matter what equilateral triangle I'm dealing with, the angles are just 60 degrees. That's it. That's all we can really say on that one. So if I look at this triangle, R, S, and T are all the same. I know that because all the sides are the same. So that means that the measure of angle R equals the measure of angle S equals the measure of angle T, which means they are all 60 degrees. That's all. That's it. Nothing fancy about that one. Okay, this one down here, this one's going to be another system of equations to solve. So I'm going to start with this. I'm going to recognize that I have an equilateral triangle. So that means all angles inside are 60 degrees. So that means that I can set up my first equation as 5x plus 2y equal to 60. I also notice that I'm going to have a linear pair or exterior angle theorem, whichever one works. So I recognize that this angle is going to be 120 degrees because it's either equal to the sum of 60 and 60 or 60 plus 120 equals 180. Okay, so that means my second equation is going to end up being 6x plus 12y equal to 120 degrees. All right. So from here, I'm going to go ahead and do my elimination again. I could do division. Yeah, let's do division or multiply by a fraction. I'm going to turn this, I'm going to multiply by a negative 1 over 6. The reason I want to do that, I'm just going to rewrite the top one. That's 5x plus 2y equal to 60. Okay, and then this one, negative 1 6 times 6 is going to give me negative x. Negative 1 6 times a positive 12 is going to give me a negative 2. And then negative 1 6 times 120 is going to give me a negative 20. Okay. Now I can cancel out my y's. So 5x minus x equals 4x. 60 minus 20 is 40. Divide by 4, and I get x equals 10. Okay, so then I can do 5 times 10 plus 2y equals 60. 50 plus 2y equals 60. 2y is equal to 10. Y equals 5. There it is. There's my system of equations. There's my x and y values. Okay, and that's answers to some homework. That's it. Isosceles, equilateral. Okay, isosceles got their special properties. Equilateral has its own special properties as well. And that is it for 6.1 day 2. We will continue some work with triangles on the next video. All right, have a nice day, everybody. Take care.